All right, ladies and gentlemen, welcome back and thanks for tuning in. This is an AP Chemistry Stoichiometry refresher. If you're in my pre-AP class and you're tuning into this accidentally, you probably, unless we've been through the stoichiometry unit already, you want to jump back. I'm going to make a couple of assumptions here for my AP Chemistry kids who have seen stoichiometry and been through stoichiometry and pre-AP before. So this is definitely not for the pre-AP kiddos. So for my AP students, this is a general stoichiometry refresher. I know it may have been some time for my seniors, maybe even 2 years since you've seen stoichiometry. So I definitely want you to be able to function right out of the gates with this. So what I've got over here on the right area is what I'm going to refer to as a stoichiometry map. And there's a couple of things going on over here. Notice there's really just four units that we're going to relate to each other with stoichiometry. The first is grams, second is moles, and then particles. Particles is a little unique because that can be atoms, ions, or molecules, so there's a couple of things that can fit into that particles category. And then liters, when we talk about liters, we are talking about volume of gases here. And then notice everything in here is at STP. Notice for all the liters, and so if we're working with stoichiometry and just standard stoichiometry, we're making the assumption that we are at standard temperature and pressure conditions. So if there's anything other than that, we actually have to use the ideal gas law and Pivnert to make those kinds of corrections. All right, and so the stoichiometry map is really easy to use once you get it into your head. There are a couple of things, or one main thing, the way that I've got this set up, is the direction of the arrows actually makes a difference. And it's really easy to remember when you start drawing this out. Remember, make sure that your arrows are always pointing away from moles, because the direction of the arrow means multiplication. So if you're moving with an arrow, so I guess I should say in direction of arrow, I'm just going to say equals multiply. All right, and so the opposite is true. If we're going against arrow, then we are actually going to be dividing. And so, for example, let me pick out a color here I haven't used over here. So if I'm going from moles A to grams A, I would multiply. And if I'm going against the grain there, I would actually divide. And then the other thing about this, you see that formula mass is actually over the arrow. That's what I would be multiplying or dividing by. All right, so if I'm going from moles A to liters A, I'm at STP. Then if I'm going up that direction, I'm going with the arrow, so I'd be multiplying by 22.4 liters. If I'm going from liters to moles A, so I'm going the opposite direction, I would be dividing by 22.4 liters, all right? So whatever the number is over the arrow, whatever the factor is over the arrow, that's what you would be multiplying or dividing by. Now, the one unique thing here as well is notice if I'm going moles A to moles B, it's multiplication going either way, and those are our molar ratio. Like 1 mole of A is equal to 1 mole of B. Normally, that's a balanced equation, but sometimes we do get into the fact that we're looking at subscripts and element relations there as well. All right? Okay, so how do we use the map? It's really pretty simple. There's only 3 rules. Make a plan, do the plan, and include all units. That's really all you need to know to be able to do stoichiometry with this stoichiometry map, other than having the map memorized. Okay? So let's do a couple of really simple ones here right off the bat. The first one that we can do, let's say I've got 18.23 grams of water, and I want to know how many moles of water are there. All right, and so notice something else here that I didn't discuss earlier. I've got water and I've got water. My molecules are the same, and so I would be going from an A to an A. All right, so technically speaking, this would be a grams A to a moles A conversion. So my plan, according to what I've got here, I would be going in this direction, right? So I would be dividing by formula mass. So my plan is essentially just to take that and divide by formula mass. Well, I take water, and I've got H, well, I guess I've got H, which is 1.008. I've got oxygen, which is 16.00. This is times 2, and so I end up with 18.016 grams. All right, and that is grams per mole is the formula mass of water. And so my plan was just to divide by formula mass. I'm going to do the plan. So 18.23 grams of H2O. I'm including all units everywhere. And then I'm going to be dividing that by 18.016 grams per mole of H2O. And again, guys, make sure you're putting the molecules everywhere where you're doing this. Otherwise, you are going to get yourself in trouble. All right, and so what I've got there is 1.01. I'm going to say 1.012, and that would be moles of H2O, because again, the reason we do this and we include all units is, notice, grams of H2O actually cancel out. I'm left with moles of H2O. My units should match up. All right, and so nothing crazy. Again, looking at the stoichiometry map, if I'm going from grams A to moles A, I'm just dividing by the formula mass. And so I'm going to go ahead and erase this. You have room. You can keep going. I want to keep the stoichiometry map up here on the screen. All right, and so I'm going to be working over in this area here. All right. The next one that we could do is, let's say that we have 23 grams. I'm going to stay with water just because I've got the formula mass already ready. And let's say we want to know how many molecules of water we got. All right. So we want to know molecules of water. Well, remember, molecules of water, molecules is actually a type of particle. And so in this particular place, I would go from grams A to moles A to particles A. And so my plan here would be, again, I'm just following across here. I was going to divide by the formula mass and then multiply by Avogadro's number, which is 6.02 times 10 to the 23rd. So make a plan, do the plan, include all of the units. All right? So 23 grams of H2O. I'm going to divide that by the formula mass. We got that a second ago, which is grams per mole. And again, making sure I'm using my molecules there. And what that's going to do is that will actually equal out. Give me a second here. I'm going to type that in. I get 1.28 is what we'll say, 1.28, and that would be moles of H2O. And then again, I'm just going to multiply by Avogadro's number at this point. All right, and so that would be times 6.02 E23. And so I get 7.69 E23 molecules of H2O. And so again, nothing too crazy here. If we're sticking with the same molecule, we're just doing an A to an A. All right, we don't need a balanced equation or anything like that, but we definitely do need to make sure that we include all the units and just remember the stoichiometry map. And so again, this is just a basic introduction to this, ladies and gentlemen. I know it's just a couple of examples, but really it's not as crazy as you might have remembered stoichiometry to be. And so hopefully that makes sense. I'm going to do one more example with you here, because again, I'm not trying to teach stoichiometry all out. I'm just trying to get you to remember what you already know. All right, and so in this particular case, let's assume that we are at STP, and I'm going to start with 22.4. I don't want to start with 22.4. Let me make up a different number. I'm going to say 5.6 liters of H2O, and I'm going to assume we're in the gas phase here. All right, and I want to know how many. Let's say how many grams of H2O I've got here. All right, so notice my molecules are the same. I'm an A to an A, so I'm going from liters of H2O to grams of H2O. My pathway here, my plan, I'm going to divide by 22.4, and then I'm going to multiply by formula mass. All right, and so I'm going to do 5.6 liters of H2O. I'm going to divide that by 22.4 liters. All right, or liters per mole of H2O, and then I'm going to multiply by the formula mass, which is 18.016 grams per mole here. All right, and so moles would all cancel out, the liters cancel out, and so I'm left with grams, and all I've really got to do is just type this crazy thing into the calculator. And let's see, times 18.016, hit enter, and I should end up with 4.50 grams of H2O. All right. So again, pretty simple. As long as you got the stoichiometry map ingrained in your head, make a plan, do the plan, include all of the units. The units are important, ladies and gentlemen, if we're going to set the stoichiometry up like this. All right. So hopefully that rings a few bells and knocks off a few cobwebs for you. I will do another video for this for part 2 when we're actually using different molecules. And so if you really need help with stoichiometry, find and start looking for that. It should be stoichiometry part 2. If you have any questions, come see me in tutorials and we'll get them all taken care of. All right. Thanks for tuning in.